The James Webb Space Telescope has made a discovery that has ignited both astonishment and speculation across the globe. For generations, humanity has gazed up at the stars, wondering what lies beyond our own world, pondering the timeless question: are we truly alone in the universe? Now, this state-of-the-art telescope, equipped with the most advanced optical instruments ever devised, has captured something that could redefine our understanding of the cosmos. Something extraordinary has emerged from its observations: a glow, a signal, possibly even the glimmer of intelligent life on a distant planet orbiting a nearby star. The planet in question is Proxima Centauri b, a rocky world orbiting the closest star system to our own. Located just over 4.2 light-years away, Proxima B has long intrigued scientists due to its position in the habitable zone, a region around its host star where temperatures could allow the presence of liquid water, a fundamental requirement for life as we know it. This planet, about 17% more massive than Earth, orbits a red dwarf star called Proxima Centauri, the closest stellar neighbor to our solar system. Despite its proximity, what we know about Proxima B is still limited, until now. Recently, while studying this planet, the James Webb Space Telescope picked up something unusual and electrifying: a steady and unnatural glow coming from the planet's night side, the portion permanently facing away from its host star due to tidal locking. This persistent glow bore an eerie resemblance to city lights, not dissimilar from those seen when observing Earth's illuminated urban areas from orbit. What made this discovery so perplexing is that these lights did not vary in intensity, shape, or pattern as one might expect from natural phenomena like volcanic activity, auroras, or reflective surfaces. Instead, they appeared structured, steady, and evenly distributed, a pattern disturbingly reminiscent of the artificial lighting associated with intelligent civilizations. Initially, the scientific community approached this observation with skepticism. Was it a data anomaly? A trick of light? An unknown natural event? But after multiple cross-checks and reanalysis, the results remained the same. The spectral data from James Webb indicated that the light emissions were concentrated in the infrared band, precisely the type of radiation one would expect from energy-efficient lighting systems or thermal emissions from advanced infrastructure. Scientists, including Dr. David Kipping from Columbia University, were stunned. According to Kipping, the thermal footprint of Proxima B defies all previously held models of rocky exoplanets. Unlike Earth, which experiences temperature fluctuations between day and night, Proxima B's night side showed a remarkably consistent warmth, suggesting either a highly dynamic atmosphere or something else entirely. The thermal consistency, especially over multiple observations, has led researchers to explore more exotic possibilities, including technosignatures, signs of technology-based life. So, what are technosignatures? In astrobiology, technosignatures refer to indicators of advanced civilizations, signals that could suggest the manipulation of the environment, energy, or matter on a massive scale. Examples include satellite megastructures, radio transmissions, large-scale solar collectors, and yes, artificial lighting. The glow seen on Proxima B is one of the most promising candidates for such a technosignature ever detected. And while no one is rushing to declare, aliens have been found, the possibility now lingers more credibly than ever before. Proxima B's unique position in the Goldilocks zone is a key factor. If the planet has an atmosphere, a subject still under analysis, it could stabilize temperatures, protect surface life from solar radiation, and support conditions for complex biology. But here's where the Webb telescope's capabilities shine. By examining the starlight passing through or reflecting off a planet's atmosphere, Webb can detect specific chemical fingerprints, or spectral signatures, of gases like oxygen, methane, carbon dioxide, and even pollutants, many of which could indicate biological or industrial activity. When observing Proxima B, Webb detected unusual ratios of these gases, ratios that do not match purely natural processes. While still inconclusive, the atmospheric profile revealed traces of methane and carbon dioxide in combination, a pairing that often hints at biological processes on Earth. More intriguingly, the presence of these gases appeared stable, not fluctuating wildly as might be expected from geological sources like volcanoes. This has prompted speculation that a biosphere, or perhaps a technosphere, might exist on Proxima B. To add another layer of intrigue, some scientists have proposed that the lights may not simply be illumination but could be part of a planetary-scale energy distribution network. If an advanced civilization exists there, they might be using solar energy harvested on the planet's day side and rerouting it via massive infrastructure to the night side, explaining the even glow. Alternatively, the lights might be used for agriculture, signaling, or even communication, either among themselves or outward into the galaxy. What if, just what if, the light is not merely functional but intentional? Could it be a signal, like a lighthouse in the cosmic ocean, broadcasting existence? Such a signal wouldn't need to be decoded in binary or pulses. Just the act of creating artificial light detectable across light years would be enough to confirm intelligence. It would be a monumental declaration: we are here. The implications are staggering. If these lights are indeed artificial, then we are likely not dealing with simple microbial life. We are likely observing a species capable of planetary engineering, of manipulating energy on a vast scale, and of sustaining infrastructure over long durations. This would suggest a level of advancement on par with or exceeding our own, a civilization that may have risen millions of years before humanity even emerged. But we must temper our excitement. Extraordinary findings require extraordinary evidence. The scientific community is now mobilizing to replicate the observations, to rule out other explanations, and to gather more data. Additional Webb observations are scheduled, along with follow-ups from Earth-based observatories like the Very Large Telescope and the upcoming Extremely Large Telescope in Chile. Scientists will continue monitoring light curves, spectral signatures, and thermal maps to further scrutinize the nature of Proxima B's mysterious illumination. Still, even in the absence of definitive proof, the discovery marks a turning point. It challenges the long-held notion that intelligent life is a rare cosmic accident. It opens up the possibility that civilizations could be common, even if separated by vast distances. If intelligent life can emerge on a planet orbiting the nearest star system, it might well exist in many more places across the galaxy. The James Webb Space Telescope was not designed to search for aliens. It was built to peer into the ancient universe, to study star formation, black holes, and distant galaxies. Yet in doing so, it has inadvertently brought us closer to answering the most profound question of all. As we uncover more about Proxima B, and as new data continues to emerge, we may be standing on the edge of the greatest discovery in human history. Imagine the moment when we finally confirm we are not alone. That somewhere out there, on a tiny dot of land beneath an alien sky, another form of life looks up at their stars and wonders the same thing we do. Who else is out there? Until then, we wait, we observe, and we keep searching. Because now more than ever, the universe seems far less silent. Stay curious, stay bold, and join us here at Discovery 2.0 as we continue to unlock the secrets of the stars, one discovery at a time.